In today's class, we are going to see how to remove the temporary hardness and how to remove the permanent hardness. Now, hardness will be caused due to the presence of calcium and magnesium associated with carbonates and bicarbonates. That means calcium carbonate, calcium bicarbonate, magnesium carbonate and magnesium bicarbonate. It causes temporary hardness. Now, what is permanent hardness? That is calcium and magnesium associated with the sulfates, nitrates and chloride. Together it will going to cause the permanent hardness. Now temporary hardness, how it can be removed? The hardness which can be removed by boiling or the addition of a lime, that is nothing but called as a temporary hardness, or we can define it as the water, where the temporary hard water is a water which is going to form a lather after treating with the soap. So this is called as a temporary hardness. And what is permanent hardness? Even though water reacting with the soaps, it is not it is not going to form a lather, or too much amount of a soap is going to be consumed. That is nothing but called as a permanent hardness. Okay, now we are going to see how we can remove this temporary hardness. Temporary hardness is going to be caused by calcium and magnesium associated with carbon and bicarbonates. This is nothing but a temporary hardness. In the temporary hardness, we are only going to concentrate the process of removal of calcium carbonate, calcium bicarbonate, magnesium carbonate and magnesium bicarbonate. We are only going to concentrate on the removal of these particular temporary hardness. Okay, in this particular temporary hardness removal method, there are two methods. One is boiling and one is the addition of lime. In boiling, we are going to concentrate on the calcium removal of the hardness caused due to the presence of calcium bicarbonate, and in the addition of lime we are going to remove the hardness caused due to the magnesium carbonate and magnesium bicarbonate. So first process, we are going to remove the hardness caused due to the calcium carbonate and calcium bicarbonate, and in the second process, the hardness caused due to the magnesium carbonate and magnesium bicarbonate. Now in the boiling process, now we have already seen that when we are going to boil the water at particular temperature, after boiling there we are going to get two kind of advantages of boiling. First one is we can kill some of the microbes which are there in the water, and the other one is whatever the agents, that is the calcium carbonate or calcium bicarbonate, after heating, what is going to happen is it is after heating and cooling it down, the calcium carbonate is going to be get settled down in the water, right? This we can get it when we boil some particular water. You have probably you have seen it when you boil the water, that after boiling and after cooling, some amount of sediment are going to be get settled down. That you have seen it when you boil and cool down the water. So what kind of a hardness we are going to remove? We are going to remove the calcium carbonate out of that. And we have also seen that after boiling, what will happen is the particle, we are going to get the evaporation, right? We are going to have the evaporated water, and after cooling it down, we can get some of the scalings on the container what we are going to use. This probably you have seen in the boiling process. Now we will see in detail how the boiling is going to help us to remove the hardness. Now calcium carbonate, that means the calcium associated with the carbonate, that is CaCO3, is being only slightly soluble in water. However, usually it is going to exist in water in the form of calcium bicarbonate. That is, normally the calcium bicarbonate will be present in water. When calcium bicarbonate is going to heat it, right? When we are going to have the water containing the calcium bicarbonate, when we are going to heat it, we are going to get the CaCO3, that is nothing but the calcium carbonate. This particular arrow, down arrow mark, is going to show that it is going to be precipitated, that it is going to get settled down at the bottom. Then we are going to get CO2, the carbon dioxide we are going to get, and which can be evaporated. That the evaporation we can have from CO2. Then we are going to get H2O. So we are getting the combination of water as well as CaCO3. This CaCO3 we can remove it by the sedimentation process. Now in this particular boiling, we cannot be able to remove the hardness caused due to the magnesium bicarbonate, that is MgHCO3 twice. We cannot remove it. Okay, now MgCO3 is fairly soluble in water. Now MgCO3 and MgHCO3 we cannot remove it from the boiling. Okay, since magnesium carbonate and magnesium bicarbonate are fairly soluble in water, this particular boiling doesn't remove the hardness caused due to the presence of magnesium carbonate and magnesium bicarbonate. It is going to be removed by the addition of lime process. So here in the first process, we can only going to remove the hardness caused due to the calcium bicarbonate. Carbonate, it is completely soluble, so it is present in the form of calcium bicarbonate. So we can remove the hardness caused by boiling. We can remove it by the boiling method caused due to the presence of calcium carbonate and bicarbonate. Now the second process is the addition of lime. Now lime in the powder form, when it is not reacted with water, its formula is CaO, that is calcium oxide. So here when it is going to react it with water, that means this lime powder we are going to add it in water. After adding this particular lime powder, it is automatically converted into the hydrated lime. So the formula for hydrated lime is CaOH2. Now here in the temporary removal process, in the addition of lime process, we are going to concentrate more on the temporary hardness removal by the hardness caused due to the magnesium carbonate and magnesium bicarbonate. So we are going to remove hardness caused due to magnesium carbonate and bicarbonate. So in the first reaction, the hydrated lime, right, in water we are going to add the lime, then it is going to be converted into hydrated lime. When it is going to react with the water, with the hardness is caused due to the MgCO3. This MgCO3, it is nothing but the hardness caused in water. It is going to react with CaOH2. When both are going to react, it is going to form MgOH2. This magnesium hydroxide is going to be collected downside as a precipitate. So it is going to get settled down, and along with the liberation of calcium carbonate. So again it is going to be collected in the form of precipitate. Now here we have removed the magnesium carbonate, that is the hardness caused due to the presence of carbonates. First we have removed it, magnesium carbonate. Then we will be concentrate on the hardness caused due to the second type, that is a magnesium bicarbonate. So if in a water the hardness is caused due to the magnesium bicarbonate, it is going to react with the hydrated lime. It is going to form the calcium bicarbonate, right? It is going to form the calcium bicarbonate along with the magnesium hydroxide. This magnesium hydroxide, it is going to be collected down as a precipitate, and we are going to remove it. And also we can remove the hardness caused due to the calcium bicarbonate. Also we can remove it along with the hydrated lime. It is also going to form CaCO3 and H2O. So we can get the H2O at the end. So here your CaCO3 or your calcium bicarbonate or magnesium hydroxide, calcium carbonate or magnesium hydroxide, all these, what we are going to have is the down arrow mark. We are going to get it as a precipitate, and we can remove it by the process of sedimentation, which has been already told to you in the previous classes. Now we will discuss how to remove the permanent hardness, right? So what is permanent hardness? Permanent hardness is going to be caused due to the presence of calcium and magnesium associated with the sulfates, nitrates and the chlorides. So when the calcium sulfates, calcium nitrates, calcium chloride or magnesium sulfate, nitrates and chloride are present in water, it is going to cause the permanent hardness. This permanent hardness, we cannot remove it by the process of boiling or addition of lime. We are going to use the two processes, that is, the processes are lime soda process and zeolite process. In the lime soda process, as the name is indicating, that we are going to use the two elements, that is lime and soda. That is, lime is having the formula CaOH2 and soda is having the formula Na2CO3. So this lime and soda, we are going to use these particular two elements. So that is the reason why we are going to use, in order to remove the permanent hardness, that is calcium and magnesium associated with sulfate, nitrate and chloride. If we want to remove this, we will be using the first process is the lime soda process. Now the second process is the zeolite process. So we are also going to call it as the base exchange, or we are also going to call it as the cation exchange process. We call this particular zeolite process or base exchange process